Every time you ask an artificial intelligence to write an email, generate an image, or summarize a document, a physical valve opens. Somewhere in the world, miles of underground pipes vibrate as thousands of gallons of fresh water are pumped into a high-security warehouse. We have been trained to think of the cloud as an ethereal, weightless place of pure light and code. But that is an illusion. The cloud is wet. It is loud. It is incredibly hot, and it is currently drinking our rivers dry. To understand why computers need to drink, we have to look at the laws of thermodynamics. Inside an AI data center, millions of transistors are flipping billions of times per second. This processing creates massive friction at the atomic level, generating concentrated heat. If a chip gets too hot, it slows down or melts. For decades, we cooled these chips with simple air conditioning. But the latest generative AI chips are different. They pack so much power into such a small space that cooling them with air is like trying to cool a roaring bonfire with a hand fan. Today, data centers must rely on water. Some systems use water to absorb heat and then evaporate it into the atmosphere to cool the air. It is the exact same mechanism as human sweat. To keep from running a fever, the cloud must constantly sweat. And just like a sweating athlete, it needs a continuous supply of fresh water to keep going. Here is the first major misconception. For years, big tech companies have boasted about their dropping carbon footprints and high power usage efficiency scores. They claim their data centers are greener than ever. But this metric hides a dark trade-off. To lower their electricity use and look green on paper, data center operators switched from power-hungry air conditioning to evaporative water cooling. By spraying water directly into the hot air streams, they cool the servers using fractionally less electricity. But that water is not recycled. It is evaporated, lost to the local watershed forever. By optimizing for energy efficiency, tech companies successfully traded their carbon problem for a water crisis. They cured their electricity fever by draining the local wells. This trade-off is creating a geopolitical crisis because of where these data centers are built. They are not placed near abundant water sources. Instead, they are built where land is cheap, tax breaks are generous, and fiber optic lines are already laid. This often puts them in direct competition with local communities in hyper-arid regions. In places like Arizona, massive data center campuses are being built right next to agricultural fields and residential neighborhoods that are already facing historic water restrictions. While local residents are told to limit their water use and farmers are forced to let their fields go fallow, the windowless warehouses next door are permitted to consume millions of gallons of drinking water every single day. In 2026, researchers published a landmark framework analyzing the hidden cost of this digital infrastructure. They argued we must view the physical footprint of AI through three distinct lenses. First is environmental justice, which asks who bears the immediate cost when a local aquifer is depleted. Often, it is rural and lower-income communities who watch their municipal water rates spike, so a tech giant can train a new chatbot. Second is climate justice. The massive water consumption of these facilities is often exported from wealthy urban areas to poorer regions where environmental laws are lax. And third is multi-species justice. When data centers discharge their used water back into local ecosystems, that water is often much warmer than the natural river temperature, altering fragile aquatic habitats, lowering oxygen levels, and triggering massive algae blooms that suffocate local fish populations. The collision between virtual progress and physical survival is no longer theoretical. In municipalities across the globe, local governments are quietly pushing back. Towns are discovering that a single large data center can consume up to a quarter of the entire city's water supply. When a dry summer hits, local officials are forced to make a choice. Do they cut off water to the homes of the taxpayers who elected them? Or do they restrict water to the multi-billion-dollar tech facility that promises to put their town on the technological map? In many cases, non-disclosure agreements signed during the construction phase prevent citizens from even knowing how much water these facilities are legally allowed to take until the wells start running dry. The tech industry is scrambling for solutions, but every fix comes with a physical or financial cost. Some companies are transitioning to direct-to-chip liquid cooling. This is a closed-loop system, similar to a car radiator, where water or a specialized fluid circulates through the servers to absorb heat, cools down in a closed loop, and is reused. It consumes almost no water, but it requires a massive amount of electricity to run the pumps and chillers. Other companies are trying to use recycled municipal wastewater, known as gray water, to cool their systems. While this spares local drinking water supplies, treating and transporting wastewater requires highly specialized infrastructure that most cities simply do not have. There is no free lunch in physics. You either burn more fossil fuels to run closed-loop cooling, or you evaporate precious freshwater. We have built a civilization where our most advanced intellectual tools are tethered directly to the basic resources of the earth. Every line of code, every automated image, and every virtual assistant relies on a physical network of pipes, pumps, and rivers. The next time you type a prompt and receive an answer in seconds, remember that the response did not just come from a mathematically perfect network of virtual neurons. It came from a machine that had to take a drink of water first. The real question is how much longer we can afford to keep paying the tab.